Welcome to this tutorial on CIVA Education Guided Wave Testing module. This module provides the possibility to compute dispersion curves in a given component. Open the Mode Computation module with a planar default configuration. Open the Specimen panel. You can modify the dimensions of the component, with y being the component's length, the propagation direction for guided waves. You can define another material. For instance, you can select titanium from the materials database. In the case of a planar component, the surrounding environment is assumed to be air. In the simulation settings, adjust the desired range of frequency, for instance from 1 kHz to 1 MHz with 500 values. Then run the simulation. 4 graphs are displayed: energy velocity properties versus frequency, phase velocity, wave number, and wavelength. Those curves show ultrasonic modes that can be generated in this component with a given actuator. You can measure modes properties with cursors and zoom in with the Control key. You can filter the displayed modes to visualize only S, A, or SH modes and change their color. To modify the model, you can go back to the model page and change the parameters or load another default configuration. Let's launch a default configuration with a tube. Define an attenuation law for L and T waves. CIVA will derive this law to compute the attenuation of guided modes in the range of frequencies of this simulation. An internal fluid medium can be defined to simulate a filled pipe. Define the frequency range, tick attenuation to account for the attenuation law, and run the simulation. Dispersion curves are provided for longitudinal and torsional modes. A graph is available for attenuation laws from the Scan Explorer. You can also display the displacement or stress components for each mode. Thank you for watching this video. If you want more information, please visit our website or contact us at contact@extend.com.